Hey everyone, it's Miss B, and in this video, we're looking at the Unit 6, Lesson 4 cumulative practice problems. So let's hop into this. This one was about distances and circles. So we used the Pythagorean theorem to find distances, and now we're using those distances to do equations of circles. So if the radius is 3, so we're actually first we're matching. So sorry, I'm like getting ahead of myself here. I'm going to start looking at A. So a circle centered at 0, comma, -4 with a radius of 3. So we learned that there is H and K and R. This means that H is 0, K is -4, and that R is 3. But our general formula for a circle here, let me just write this actually in a little bit more of a bold font, and I'll write it in black at the top next to where I would put my name normally. So this would be x minus h, and then we would square it, plus y minus k, and then square it, and it's equal to r squared. So, since we need to be equal to r squared, we don't want to fall into the trap of something with a radius of 3 then being equal to 3. It's going to be equal to 9. So, I'm going to match up A, B, C, D, E here. I don't have a ton of space in between to match it. So, I'm just going to write um, the number on the left-hand side here that goes along with it. And I'm going to circle or cross things out as I go, I guess, to indicate that I've matched something with it. So a circle centered at 0, -4. So x plus 0 squared is really just going to give us x squared. So that's actually going to be this question here, or the option here, number 2. And we even know that a minus a negative gives us a positive. And 9 here, this is 3 squared. So this one works perfectly. Number 2 goes with A. For B, a circle centered at 1, comma, -4, and a radius of square root of 3. So when we square that, that's going to be whole number 3. So we want an x minus h, and then minus k, so x minus 1, and y minus -4. And then it's going to be equal to 3. So it's either going to be number 4 or 5 down here. And since number 4 is equal to 9, 5 is the one that's equal to 3. So 5 goes with B. For C, this is circled at, it's a circle centered at +1, +4. So I'm going to have two minuses, x minus 1 and x minus 4. And again, it has a radius of √3. So it's going to have equal to whole number 3. So that's going to give me option 3 right here. 3 goes with C. Then D, this circle is centered at 1, comma 0. So we're going to have x minus 1 and then y minus 0. And y minus 0 is just y. So that leaves us with the only option being number 1 up here, x minus 1 squared plus y squared is equal to 9, and that checks out because our circle has a radius of 3, and 3 squared is 9, so this is 1. We're going to double check that E should match with number 4 because those are our only two left. If it's centered at +1 and -4, then we should have x minus 1 and y plus 4, and we do. And equal to 9, which means radius of 3. So indeed, this one does match with 4. So yeah, just a little bit of matching there. They just didn't give us a ton of space. So yeah. Then let's move to number 2. So write an equation of a circle that is centered at -3, comma 2 with a radius of 5. I can actually do that without any of this multiple choice stuff. So let's write one and then see which one it matches at. So, all right. Let's say if it's centered at -3, comma 2, so that's going to be h, this is going to be k, and this is going to be r, I am going to have x minus -3 squared, so plus 3 squared, plus y minus k, which is 2 squared, is equal to r, which is 5 squared, which makes 25. Now it's okay to write it as 5 squared, but most times you'll find that they don't in the curriculum here when they give you options. So which one of these matches with mine? X plus 3 squared, y minus 2 squared, and 25. Well, definitely not A and B because those have 5s, and that's wrong. So my option or my answer here is D, because D is the one that matches with my equation exactly. I have x plus 3 squared plus y minus 2 squared equals 25. Okay. Right. Question 3 here says, plot the circles x squared plus y squared equals 4 and x squared plus y squared equals 1 on the same coordinate plane. Find the image of any point on x squared plus y squared equals 4 under the transformation of x comma y is changing to 1/2 x, 1/2 y. And then they're going to ask us, what do you notice about x squared plus y squared equals 4 and x squared plus y squared equals 1. So we'll start with part A. X squared plus y squared equals 4. Well, this means if I'm looking through here that h, oops, that's a little thick, h is 0 and k is 0 and r, in this case, 2 squared is 4, so our radius is 2. And then same with this one below it, this is h being 0 and k being 0, but then the square root of 1, or the radius here, is 1. So we're going to plot those in red and in blue, respectively. So they're both centered 0, 0. And let's see if my circle tool actually works nicely here. Probably not, but we'll see what we can do. Interestingly enough, I made it make a perfect circle for me. That has a radius of 1 and it's centered at 0, 0. All right, I'm gonna remove my center there and stuff and then use in red and try to draw a nice circle, but you never know what it's gonna do. I need a radius here of 2. So I know, and if you're having trouble drawing, you can always mark that you know on the directly above, below, left, and right, you know it should go 2 spaces. If you don't have a way of drawing a perfect circle, that's okay. I don't expect you to, but just try to draw your best. That's why we have equations to check where our points land on our circles. So I'm going to draw the best circle that I can, and it's going to be a lumpy, weird looking shape, but hey, I kind of made it, right? And then now I get the benefit of being able to move mine a little bit. So I'm going to do that so that it lands right on there. Okay, cool. All right, so they're now asking me, what do I notice about I'm going to have a transformation here. So x squared y squared equals 4. So that's my red one. So just for me, I'm going to say this was my red one. And then they want me to do half of the distance of x, or half of the coordinates for each of these. So let's start with this red one here. And we'll say this point right here at the top. If I go half of the distance, well, this is 0, 2, half of 0 is still 0, and half of 2 is 1. So it actually lands, on that blue circle. And you're going to notice that each and every point that you might start with on the red circle, or on my red circle, yours probably not red, but those are all going to land on the blue one. So they're saying, I will actually write out a transformation here of 0, comma 2. That's going to become, in the image, 0, comma 1. What do you notice about the two? They are a dilation of each other. So they are similar. We can say that x squared y squared 1 is a dilation of x squared plus y squared equals 4, centered at the origin with a scale factor. Oh man, my writing is getting sloppy. I'm trying to go fast. With a scale factor of 1/2. So it's basically that same circle, just under a transformation. And they're centered at the same place. And since that center is also the center of dilation, they're kind of just like right inside of each other there. But that's it for the first page. So that's going to take us onto the back of this page, where we only have 3 more questions, but number 6 is going to be some matching, but it shouldn't be too bad. So let's start with number 4 here, though. Number 4, x comma y is going to become x minus 3 and 4 minus y. That's an example of a transformation called a glide reflection. And we're going to complete the table using this rule. So if you're finding that you have some difficulty with this, it's really only 2 points, but I'm going to do both of my x coordinates first. And I'm just going to subtract 3. So 6 minus 3 is 3. And 3 minus 3 is 0. So it's okay to do one at a time. Now the next part, I'm going to do 4 and then subtract the original y value from it. So for my input values here, well, my input value was 6 comma 1, so we're going to take 1 and do 4 minus 1. 4 minus 1 gives 3. 5 minus 1 gives 4. Wow, not minus 1. It's y, 4 minus y. So we're going to do 4 minus 5. Jeez. 4 minus 5 is negative 1. So even that one trips me up a little bit, but we can still make it through. So is it going to be congruent to the original? Well, kind of, yeah, basically. We're not really applying a scale factor to any of these. Changing the sign of a number is not really going to give you a number. It's not going to give you a coordinate that really ends up much different. So here, x minus 3 is a transformation or translation, but the 4 minus y, let's look at the way we can write 4 minus y. You could also write that as negative y plus 4. So this is kind of like a reflection and translation. And it's okay for reflections to only affect one variable. That's actually how it normally works. We would normally have like x and then like negative y. It just also means that we're combining a translation into this. by going 3 units to the left and 4 units up. So the translation is 3 left, 4 up. And then the reflection is if we took like x, y, and it just became x negative y, and that's across y equals 0 or the x-axis. So it's a glide reflection, which is really just a combination of a reflection and a translation. So long story short, yes, it produces a triangle congruent to the original because those are both rigid motions. So we can say yes, because it is made of 2 rigid transformations. And I'm going into my table a little bit, but that's okay. Maybe just to make things neater, I'll kind of scooch this across. That way I'm not crowding myself out here. I don't know if you can hear my cat in the background, but she's chirping a little bit. So I guess she says hello. And yeah, she's saying hello. More likely she wants my attention or she wants some extra food, but she'll get plenty of attention after I'm done with this. We only have 2 questions left, and let's get this over with. So, number 5, the triangle whose vertices are 1, 1, 5, 3, and 4, 5 is transformed by the rule xy becomes 3x, 3y. Is the image similar or congruent to the original figure? Well, they're giving you some numbers, so you can always plot this and check if you want, but I think I have everything I need right here in this statement. xy becomes 3x, 3y. Multiplying by 3, that's a scale factor. This is going to be a dilation, and that means that this is going to be similar. So it is similar but not congruent. This is a dilation by scale factor of 3. And it's a scale factor of 3 centered at the origin, but I don't have to write that necessarily. I'm just writing that little note to myself on the side as a reason why it is similar but not congruent. That then brings us to number 6, which is matching each coordinate rule to a description of its resulting transformation. So let's go through. We're going to go A, B, C, D, E, F, G, and then match up what it should look like on the right-hand side. So the first one here is literally the transformation that we just talked about in the previous question. xy becomes 3x, 3y. And I said that's a dilation by scale factor of 3. That's number 7, dilate. And I even said origin is the center. I just didn't write it down. That's number 7. Dilate using the origin as a center and a scale factor of 3. Okay. For B, this one here, we're subtracting 3 and subtracting 3. This is a translation if I'm just adding and subtracting numbers. 3 negative means I'm going left, and negative here means I'm going down, so left 3 and down 3. But that's not how they phrase it, is it, huh? They say along directed line segments. But it's going to be this one right here, -3 and -3. You can kind of see when they're talking about directed line segments, if you just kind of ignore or scribble out the variables, or replace them with zeros, you would get 0, 0 to -3, -3. So their descriptions of these, like from 1 point to 1 point, is kind of if you just subbed in 0 for x and for y. So this one actually matches up with number 6. So that is 6. For C, this one is positive in both of those directions. So right 3 and up 3, it's going to be the one right above it. That's going to be number 5. So number 5. D, this one is only -3 in the x, so I'm looking for one that is -3 only in the x. That looks like number 1. So number 1, I meant to swap colors every time here. So number 1, number 1. Then our next one here is adding 3, but only on the x coordinate. So swap colors over to red. If I add 3 only on the x coordinate, that's a +3 only in the x position. That's number 3. Then we have F and G. Those should be 2 and 4. I'm not sure which one is which, but we'll check here. So let's see. F is -3 only for the y. So that's going to be number 2 because it has -3 in the y coordinate. So we would have 2, and that means G should be number 4, but we're going to check to see that it matches. And it has y +3, so we're only going to have 3 on the y coordinate. So that matches up as well with number 4. Number 4. So you had 7, 6, 5, 1, 3, 2, 4. Now there was some space to do some matching here with lines and stuff, but you don't have to. Maybe I'll draw them in here anyways. So this one matched with 1. This one here matched with 2. I'm just going to do my matching colors. Number 6 here with this one. And then my other pieces matched with red. So this top one matched with number 7 all the way at the bottom. Then I had this one here matched with number 3. And this one here matched with number 5 in the middle here. Let's get number 4 matched across. Yeah, see, this is why sometimes I just like writing the numbers, because this one here matches with 5 and that one. They all get kind of tangled in the middle sometimes. And I think that writing the numbers next to the letters or vice versa is a little easier. But there you go. That's it. That's the whole assignment. Hopefully my explanations helped out. Definitely keep in mind that you have this formula up here at the top. This is what we're using and what we're basing our circles on, and it's formed from the Pythagorean theorem. So if you don't have that in your notebook, you definitely should put it in there. But either way, this has been the Unit 6 Lesson 4 Cumulative Practice Problems for Illustrative Math Geometry.